Section 12.3 is all about odds. You'll often hear odds given at horse races, if you play craps, or any other gambling game in Vegas. If you ever hear the odds there, they are always discussing the odds against, unless they specify otherwise. So, for example, if you are betting on a horse and they said you had 20 to 1 odds, that means 20 times the horse will lose compared to 1 time the horse will win. So that's why if you ever find a situation like that and you bet on it, you make so much money because the odds are stacked against you. The odds against an event is a ratio, which remember just means fraction, of the probability that the event will fail to occur to the probability that the event will occur. To find the odds, you must first know or determine the probability of a success and the probability of a failure. The formula for odds against an event is as follows. You take the probability of a failure and divide it by the probability of a success. And that will give you odds against you. Let's look at an example. Determine the odds against rolling a 4 on one roll of a die. So the first thing you would need to determine is the probability of rolling a 4. You would also need to determine the probability of not rolling a 4. Since there are 6 items on a die and there is only 1 4 on a die, the probability of rolling a 4 is 1 out of 6. The probability of not rolling a 4 would be 5 out of 6. So you are trying to find the odds against rolling a 4. So if you were going to do that, you would take the probability of failure, which means not getting a 4, divided by the probability of success, which is getting a 4. The probability of a failure is 5 out of 6. The probability of a success is 1 out of 6. Now, if you remember from your previous math course, if you are dividing two fractions, you can multiply by the reciprocal. Some people will call it copy dot flop, meaning you copy down the fraction in the numerator, change the division to a multiplication, and flip the second fraction over. Copy dot flop. Those 6's will reduce in this situation. So your odds against rolling a 4 are 5 to 1. So you will roll non-4s 5 times for every 1 4 that you do roll. Sometimes you'll want to count odds in favor of an event occurring. If they do ask you for odds in favor, all it does is change the formula a little bit. To get odds in favor, you'll take the probability that the event occurs. So basically your success will go on the top. And then the probability that the event does not occur will go on the bottom. So the probability of a failure will go on the bottom. So it's the same formula, just upside down. So let's look at this example. The circle graph shows the United States market share for the operating system used in smartphones as of December 2010. So if you look at this pie graph, in 2010, 32% of users were BlackBerry users, 29% were Google users, 25% were Apple users, and 14% used something else. I bet if you did that poll today, the numbers would be quite a bit different. So using that pie graph, if an individual who owns a smartphone is selected at random, use the graph to determine the odds against the individual owning a Google phone. Okay, so you are trying to find the the odds that someone does not own a Google phone. So first we have to find the probability that they're not a Google owner. That's going to go in the numerator. and then you find the probability that they are a Google owner, and that goes in the denominator. Well, if you look at the pie chart, 29% of people are Google owners. So if you want to write that as a probability, 29 out of 100 people own Google. So what you could do is you could either use the complement and do 1 minus 29 out of 100, or you could add up the other categories. You could add up the apple, the other, and the blackberry. Either way, you're going to find that 71% of people are non-Google users. So as a fraction, that would be 71 out of 100. And then you'll have to simplify the fraction. Copy, dot, flop. So the probability against Google owners is 71 to 29. You could also write that with a semicolon, 71 to 29 if you want to. Same graph. If an individual who owns a smartphone is selected at random, use the graph to determine the odds in favor of the individual owning a Google phone. You could redo all of your calculations, but the only difference between odds in favor and odds against is they're flipped upside down. So this time you would want the Google users on top and the non-Google users on the bottom. So it would be 21 to 79. Last example. The odds against Robin Murphy being admitted to the college of her choice are 9 to 2. Determine the probability that Robin Murphy is admitted and Robin is not admitted. Okay, so we have odds against. So they're saying that the odds against her are 9 and the odds in favor of her are 2. So if there's 9 ways for her to not get in and 2 ways for her to get in, then that means that there's 11 possible outcomes total. So the numerator is actually 9 over 11, and the denominator is actually 2 over 11. Since this is odds against her, that means the probability of her not getting in is in the numerator. So the probability that Robin is not admitted is 9/11ths. The odds of her getting in are in the denominator. So the probability that Robin is admitted is 2/11ths. So you can take the probabilities, you can take the odds and go backwards and find your probability.